Okay, so previously we've used the gamepad object in Max to create a very basic monophonic synthesizer. You can kind of do chords with it, but it's not really using poly. So I'm taking that patch and we're going to expand on it here. I've made a couple of changes here, as you can see. I've gone through and I've listed out what the floating point outputs are for different things, like the analog stick axis on the X and the Y coordinates for the left and the right stick, and also for the triggers. And I've decided that what would be really cool would be to have the left shoulder trigger function as a velocity multiplier, and the right trigger to be a global pitch bend, which I think is kind of cool. So I've gone through here and I've added those messages into route already. So just after button A, I've got access underscore left underscore trigger and access underscore right underscore trigger. And then that's hooked up to a send for access left trigger that's called vel mult for velocity mult. And the right trigger is hooked up to a send for pitch bend, because we're going to use those internally inside of Poly, and that's going to affect every single note. I also decided that I want to be able to have a global ADSR window that's going to be the same for every note. So I've gone ahead and I've created 4 live dot dials for sends to envelope attack, envelope decay, envelope sustain, and envelope release. So env A, env D, env S, and env R. With these, I have a range of 0 to 2000 for everything for ADNR, and then sustain is floating point, because sustain is always a decimal that is in the 0 to 1 range. So we've got ranges for those. And then I do have defaults set to all of these. So we have a default envelope of 10 milliseconds of attack, 20 of decay, sustain at 0.75, and release of 250 milliseconds. Now I also like to play around with pitch bend, so I created a SPB range to send that into Poly when we create our Poly. And from there, this pitch bend range goes anywhere from 1 to 6 semitones that we're going to be able to use. And the default for that is 2. So, how are we going to do this? And the answer is, first and foremost, we're going to unlock the patch. And yeah, we've got basic sounds right there, and everything works. And we're going to go through all of these subpatches, the notes subpatches, and we're going to nuke them. Then what I'm going to do is I'm going to create a MIDI format box. And what that's going to do is it's going to prepare data in the form of a MIDI message. And I'm going to connect all of these messages of notes and velocity on and off pairs to that leftmost inlet of MIDI format. So I'm just holding down Shift and clicking on these from that first inlet of MIDI format. And that is that. So pretty easy. Now we need to construct the Poly, which is going to be a little bit more complex. And from my own experiments working with video game controllers in Max, this can be a little hit or miss, and it just kind of is a little wonky and not as standard as Poly would normally be. So I'm going to create a new patch. We'll expand that out and zoom in a bit. And we're going to start up here with Poly MIDI in. So this is a way of getting data into a Poly that is normally used for MIDI polyphonic expression, or MPE controllers. And it's assuming that you're sending separate channels with tons and tons of MIDI data simultaneously. So that's going to go to the MPE parse object. And this is a really powerful object. I strongly encourage you to check out the help file for it and go through and look at it, especially if you're using a MPE controller for other things in Macs like a Linstrument or an X key or a QNexus or anything like that. Very great object, one of my favorites to use with MIDI. But from there, we're really only interested in the note on and note off pairs that come out of the leftmost outlet. So I'm going to create a new object of unpack with arguments of FF because it's going to pay to work with floats a lot here. Okay, so at this point, we're starting to get stuff in here, and I would be able to start sending data in here, and I'd be able to unpack it. But we do have some sends and some receives we need to take care of. So the first one I'm going to do is create a receive for vel mult, which is our velocity multiplier that we're sending from our main patch. Then I'm going to create another receive for our pitch bend. So PB. And I'm going to create a final receive for our PB range, and if I can spell it correctly, there we go. We're also going to need to have receives for our ADSR envelope, so I'm just going to go ahead and create ADSR. I cannot type, and I'm going to give it the exact same arguments as our defaults, so 10, 20, 0.75, and 250. Then I'm just going to create some new objects. We're going to do a receive, ENVA, and that goes into the attack signal or float inlet. Then I'm going to duplicate that, move it over, and connect it to the decay, so that will become ENVD for the receive. Then we're going to move these guys over, and we're going to do the same thing for S. And last but not least for R. Okay, so just to make sure that everything is good, I'm going to compare this with my other top-level patch. So I should have a vel mult spelled exactly like that, and I do. I have a PB send, lowercase p, capital B, and I do. PB range, lowercase pb, capital R, and then send ENVA, D, S, and R. All right, so that looks like it's going to work. Obviously, we're not going to know until we actually test it, but until then, we'll find out. Okay, so with pitch bending, we're going to start with that. And what I want to do with the pitch bending is I want to have a scale object. Now, I'm taking everything from my right analog trigger, and that has a range that we can see in gamepad of 0 to 1 as a float, as does my left analog trigger. So with that, I'm going to use scale. I'm going to set my low input value of 0 point, high input of 1 point, and then I think we're just going to multiply this by 2. So I'm going to do my out high, or my out low, sorry, as 1 point, and my out high as 2 point. And connect it up, that should work. Now I'm going to do the same thing. I'm going to connect my PB range, and I want that to go to the high output value. Oh, and actually I'm going to take it down. You know what? Let's go down to 0 for the low for the pitch bend. That will be really useful because then we can have absolutely no pitch bend instead of one semitone at all times. Okay, so we've got that together, and then this is connected to my high output value, so I'll be able to change that all the way from 1 semitone if I completely depress the trigger up to 6. I'm also going to insert a scale for my velocity multiplier. And again, this has a range of 0 point to 1 point for the input. And for the output here, I'm going to do 1 point and 2 point. because that way we'll always have at least whatever the velocity that we gave Poly when we sent the MIDI information into it. But at most we'll have twice as much amplitude. Okay, so now with this, I need to take the pitch bend and add that or subtract that to the MIDI information before it is converted from MIDI into frequency. So in order to do that, I'm going to create a PAK, P-A-K, with two Fs as the arguments. I'm going to connect that to unpack. Then I'm going to take my pitch bend information and connect that to the right inlet. So now I just need to add these values together. And I can do that with plus space 0 point. And I'm just going to add them into the same inlet. And then we're going to add those two values. So what's going to happen is every time I make a change with the analog trigger, it's going to convert that via scale anywhere from plus 0 to plus whatever I've currently set the pitch bend range to. And it's going to combine that into a list with the MIDI note, and then it's going to add them together instantaneously. That's why we're using PAK instead of PAK, and that's why we're going into the leftmost inlet for the plus, because it's going to add both elements of the lists simultaneously. From there, we can convert to frequency with M to F, and I'm going to initialize that with 0 point, and we're going to send that to a saw, also initialized at 0 point. So we've got that, but to make this a little bit more interesting, because, Poly, what I'm going to do is I'm going to duplicate that, and then I'm going to add an offset to the pitch to produce a note a fifth above. Then I'm going to duplicate it one more time, and we're going to change that to plus 12. So the result is that I'm going to have the note plus the pitch bend. That's going to come down here, and that will be my fundamental. It's also going to get sent out, and it will produce a note a fifth above and a note an octave above. So that's going to give me a power chord. So rock on, throw the horns. But we do need to be careful of the volume. So what I'm going to do is add a multiply audio object, 0.33, which is 1/3 of the volume, and that's going to scale things down so that hopefully we're not going to clip. All right, so far so good. Next, I'm going to do a ADSR. So I'm going to do divide by space 127 point. I'm going to connect that to the right output of unpack, which will give us our MIDI velocity. And connected to ADSR, that's going to give us a signal in the range of 0 to 1, a floating point number. So that's really, really useful. And at that point, what we can do is we can multiply our audio signal by that ADSR signal. And that will give us full envelope control. Now, I do have this velocity multiplier here. So this is where I'm going to insert that. I'm going to come down here below the envelope multiplier. I'm going to do another audio multiply by 1 point. I'm going to connect that up there, and then I'm going to take the output of our scale and connect it down to that. And so the result is that we're going to have first the envelope applied, and then we can, in theory, double the amplitude of that. Then all of that is going to go to out with a tilde because it is audio. And it's going to be output 1 because that's the lowest number. So at this point, I'm going to save this. We're going to save it on the desktop. I'm going to call it, how about Game Poly? And we're going to hit save. And it has popped up right there on my desktop. So I think we are good to start adapting the main patch, and hopefully we're going to get this working. So from MIDI format, at this point, the only thing I need to do is insert poly. And keep in mind that with poly and the top level patch and the patch that you're loading into poly, they have to be in the exact same directory or it won't work. So fortunately, I've saved both of these on the desktop. I have gamepad synth, which is my parent level patch, and then I have game poly, which we're going to load into poly. So now I'm just going to do poly and game poly, and then we need to instantiate it with a number of voices. So I don't really see myself playing more than 8 buttons simultaneously, so we're going to do 8, and hopefully that will be the maximum. I'm going to connect that to live.gain. Then here is the part that's really interesting. So the output of MIDI format typically is going to be MIDI messages coming from the left and MIDI events coming from the right. And that MIDI event is typically used for the VST object, which we'll get to later. But here, I'm going to connect it up to that right outlet of MIDI format, the MIDI event, and send that to poly. And that's because within poly, we have poly MIDI in. And that likes those MIDI events so much more than standard MIDI. So at this point, I'm going to toggle my volume and let's see if we get some sound. That totally sounds like a power chord. And it sounds like it's got volume multiplying and pitch bend. Awesome. So here's a chord. And it does, in fact, have full volume scaling and full pitch bending from the analog shoulder buttons. And I can test and make sure that this works. So we're just going to hold down a note and change the pitch bend range. And that works pretty well. If I try that, let's set it to 1. I can sort of do vibrato, but it's not not too easy with this. These buttons are a little springy, so let's try that at 2. Obviously, not great technique on my part. I need to have faster trigger fingers, if you will. But at this point, I can save it, and yeah, I have a fully working gamepad-based poly synth, and I'm starting to get into using scale to translate those analog triggers and sticks into other things. Some other things you might want to try would be taking the analog sticks and using those to control a filter. I would just insert a biquad after poly, but before the live.gain. Or you could play around with other things internal to the poly and send those via a send and receive in order to control different things, like maybe doing harmonic deviation with the MC wrapper.